Welcome to Lesson 5-4 Video 2. In Video 1, we went over some of our most basic problems that we will be using solving by square root method to figure out. Unfortunately, they aren't all that simple, so we are going to take a look at some that are going to be a little bit more complicated in this video. This is going to help us solve some quadratics that may not be in that standard form or intercept form like we mentioned in Video 1. So let's go ahead and take a look at these. So not every quadratic equation will be a one-step solution. Sometimes we will have to work to get the x squared isolated before we can take the square root. In our problems in Video 1, if I scroll back up and look at those, we already had the x squared term isolated. In this video, we're going to take a look at what we need to do to get those x squared terms isolated and then finish with solving the problem there. So we are going to have some steps for solving quadratic equations by using square roots. Our first step is going to always be to simplify each side of the equation by distributing and combining like terms. This is going to be something very similar to when we were solving equations in Unit 1. That was basically our first step anytime there. We had to distribute and we had to combine like terms. And just like we were doing in those equations, the next thing we would have to do is move all the variables to one side of the equation. Get all our x squareds and x's over to the same side. The next thing we're going to do that's going to be a little bit different is we're going to get x squared by itself using inverse operations instead of just getting x by itself. Once we get x squared by itself, then we are going to want to take the square root of both sides of the equation. And just another reminder, we talked about this in the reminder box up here, but there will always be a positive and a negative answer. Unless you get that rare case where you get a situation where your answer is 0, when you take that square root, you got to make sure you put that plus or minus sign in. So let's go ahead and look at a couple examples. So looking at example 3, we are given the quantity 4x minus 6 squared plus 3 is equal to 12. And what we are going to need to do is to follow those steps that we just talked about. So I'm going to check to see if there's anything that I need to distribute, or if there is anything that I need to combine like terms on. I do not have anything outside the parentheses to distribute, and I can't combine any like terms because I have that negative 6 and I have the positive 3 that are separated by those parentheses. That parenthesis there is going to trap that negative 6 inside there, and we're not going to be able to combine it with the positive 3. So I do have all my variables on the same side of the equation, so then I'm going to need to move on. Now, one thing that I'm going to see that's a little bit different and a little bit outside of those instructions is that my squared term is going to be actually the 4x minus 6. So before I take the square root, I'm not actually looking at getting the x by itself. I have to look at getting that whole squared piece by itself first. So what I'm going to do is get that part all by itself. So to do that, I would subtract 3 from both sides. So I'm going to get, still in parentheses, 4x minus 6 is equal to now 9 when we do that subtraction. Now I want to make sure I keep my squared symbol there. So now is when I'm going to take that square root. I need to get that squared away from the set of parentheses, so I will take the square root now. So when I do that, that is going to cancel out my square root and my squared term, since those are inverses. And on the left, I'm going to be left with 4x minus 6, and on the right I'm going to get the square root of 9, which is going to be plus or minus 3. Now we do need to continue on, and we need to get x by itself, but now we have basically a regular equation. So we have 4x minus 6 is equal to plus or minus 3. What I'm going to do now is I'm actually going to set this up as two different equations. I'm going to do 4x minus 6 equals that positive 3, and I'm going to solve that, and then I'm going to set up the same problem, but instead of using the plus 3, I'm going to use the negative 3. And this is going to be how I get my two answers. So to solve this equation, I would add 6 to both sides. So I would get 4x is equal to 9. I would divide both sides by 4 and get that x is equal to a positive 9/4. And then I'm going to work this problem. I'm going to add 6 to both sides, just like I did above. This time it's going to give me 4x is equal to 3. So I am going to then divide both sides by 4, and I'm going to get x is equal to 3/4. So we have our two answers. We have x equals 9/4 and x equals 3/4. We got those two answers because one time we looked at taking the positive square root, and one time we looked at taking the negative square root. Alright, now let's take a look at example number 4. In example number 4, we are going to need to go ahead and do some distribution. We're going to take that 2 and we're going to multiply it through the parentheses. We're going to get 2x squared minus 10 is equal to negative x squared minus 1. The next thing we're going to need to do is to get our variables on the same side of the equation. So I am going to add an x squared to both sides. That is going to give me a 3x squared minus 10 on the left. Those x squareds on the right are going to cancel, and I'm just going to have negative 1. Now looking at this, we want to see what that squared term is attached to. In this case, that squared term is only attached to the x. That 3 and the minus 10 are not in parentheses, they're included with the x squared. So we are actually just looking at getting the x squared by itself this time, and then taking the square root. So to do that, we will add 10 to both sides, and that is going to give us 3x squared is equal to a positive 9. Remember, we are trying to get this x squared by itself, which is still not the case because we have that 3 in front of it. So we need to divide both sides by 3. The 3's will cancel. We'll have x squared is equal to 3. So now we do have that x squared term by itself, so we take the square root of both sides. On the left, our squared and our square root symbol are going to cancel each other out. And so, remember, when we take the square root of a number here, we cannot simplify the square root of 3. That's as simple as we can get. So we are going to put x equals plus or minus the square root of 3, so that we show both answers for when we take the square root. If this were to simplify, we would simplify it, but since the square root of 3 is as simple as we can get, we will just leave our answer as is. Alright, there are 2 you-try problems for you guys to attempt. Go ahead and give those a shot. Make sure to check your answers on the website, and then be sure to return to video 3.